Hello everyone. Today we are going to learn remainders. Let us first try to understand what is the meaning of remainder. Let us consider a division. Say 23 divided by 5. Now everyone knows this is a simple calculation. The quotient is going to be 4 and the remainder is going to be 3 because 5 into 4 is 20 plus 3 is the remainder. But let us have a better understanding about the remainder with the help of a number line. What I'm doing here is I'm writing down the multiples of 5. So 0, 5, 10, 15, 20, 25 and so on. There will be infinite number of multiples. But I'm interested in the number 23. 23 should be somewhere here, right? Now I'm going to define remainder with two reference points. The reference points are 20 and 25. 20 is a multiple of 5 and 25 is also a multiple of 5. Now if you look at 23, 23 is 3 more than 20 and 23 is 2 less than 25. This is what we call as remainder. If I have to elaborate, I can write 23 as 5 into 4, which is 20, plus 3. I can also write 23 as 5 into 5, which is 25, minus 2, which means the remainder here can be either plus 3 or minus 2. That is what we call as positive remainder and negative remainder. So what we learn here is a basic thing that every division has two possible remainders. One is positive and the other is negative. It is other thing that we always consider positive remainder as an answer, right? We always consider positive remainder. When it comes to question solving, we consider the positive remainder as the answer. Let us have one more example to have better understanding. Let me consider division 46 divided by 8. Now here the divisor is 8, so I will have to plot the multiples of 8. So which is 0, 8, 16, 24, 32, 40, 48 and so on further. Now remember, I am plotting 0 also as a multiple of 8 because 8 into 0 is 0, 8 into 1 is 8, 8 into 2 is 16 and so on. Okay. Now 46 is a number which is somewhere here. Now this 46 is 6 more than a multiple of 8 or it is 2 less than a multiple of 8. So I can write 46 as 8 into 5 plus 6, which is positive remainder, or I can also write 46 as 8 into 6, 48 minus 2. So I got two remainders. One is positive remainder and the other is negative remainder, right? So far we have learned two types of remainders. One is positive and the other is negative. Now there is one scenario where the question becomes very simple. Suppose the question is 15 upon 20. Okay, now if you look at this numerator in this question, okay, let me first draw the number line. The number line would be again 0. I will have to plot the multiples of 20, 20, 40, 60 and so on, right? But if you look at the dividend, which is 15, 15 lies in the first gap, so it is somewhere here. Now I can write 15 as 20 into 0, which will be 0 itself, plus 15, or I can also write 15 is equal to 20 into 1 minus 5. So the remainders are plus 15 or minus 5, which I can also say 15 is 15 more than a multiple of 20 or it is 5 less than a multiple of 20. So now what do we learn in this example here is that the numerator is smaller than the denominator. If I have to generalize, suppose your division is a upon b where a is less than b, then I can also say a is itself the remainder, because if you check the question was 15 divided by 20 and 15 itself is the remainder. and that is positive remainder. We can also refer to the remainder as negative, which is minus 5 all the way, but the remainder will be plus 15. So if I consider one more example, say 23 divided by 40, the remainder here should be clearly 23. That is positive remainder. If I have to talk about negative remainder, it has to be 40 minus 23. So the remainder could be also minus 17. Okay, so positive remainder is what we are looking at, and negative remainder is also possible in the scenario here. So we have learned three things so far. One is positive remainder, second is negative remainder, and third is a special case where the numerator is smaller than the denominator. Then the numerator itself is the remainder. Now let us try to use these concepts in question solving. Check this question. What is the remainder when 395 plus 1283 plus 970 is divided by 6? So this is the question basically. Now the most basic way would be to find out the sum of numerators and then divide by 6, but we are going to learn a shortcut method here. Okay, the shortcut method involves calculation of remainders with each term of numerator. So we have to first calculate what is the numerator, what is the remainder in 395 divided by 6. So if you divide this number by 6, 6 is 36, 3 is remainder 35, 6 5 is 30. So the remainder in the first calculation is 5. Okay, we'll proceed further with the next calculation. 1283 divided by 6. Okay, 6 2 is 12, 6 1 6, 2 remainder 23, 6 3 is 18, which means 5 is the remainder in that case as well. Then we have one more number, 970 divided by 6. So what we are doing basically is we are trying to find out remainder with each term in the numerator. So 970, 6 1 6, 37, 6 6 36, 1 10, 6 1 6 means 4 is the remainder. I hope you are comfortable solving the remainders of simple calculations like this. So what we did so far is, instead of calculating the addition of all the three numbers, I am simply finding the remainders of each term and then divide by 6. Okay, if you continue further, 5 plus 5 is 10, 10 plus 4 is 14, 14 divided by 6. The remainder in this case, now I hope by now you should be able to do it very quickly. 6 2 is 12, so plus 2 is the remainder. Okay, so this process is called as remainder theorem of addition. Okay, so this reduces your time of calculation because we are not going to solve the calculation in the numerator. Okay, you can verify this calculation. 1283 plus 970 plus 395. Okay, you can add them all. 5 plus 3 is 8, 9 plus 7 is 16, 16 plus 8 is 24, 4 carry is 2, 9 plus 3 is 12, 12 plus 4 is 16, 6 carry 1, 1 plus 1 2. So basically it would have been 2648 divided by 6. Okay, and the remainder in this case would be 6 4s 24, 2 remainder 24, 6 4s 24, and then 8 6 1 6, the remainder will be 2. So you can see it is verified. So what we are doing here is we are reducing the efforts of addition of all the numerators and directly jumping to the solution by finding remainders in each term. So the first term has a remainder of 5, second term has a remainder of 5, third term also has a remainder of 4. Then you add them and divide by 6 finally. Let us try to use the same concept in this question. Okay, you can pause the video and try it on your own, and then if you can't solve it, check the solution further. So the process is simple as we discussed so far. 24 divided by 7, so we will first find remainder in this case. Okay, 7 3 is 21, so 3 is the remainder. Then 34, 7 4 is 28, there is 6 is the remainder. Then 44, okay, this is done. 44, 7 6 42, 2 is the remainder here. Then 54, 7 7 is 49, 5 is the remainder. And then the last number 7 9 is 63, 1 is the remainder. So see, it is very effortless. We have to simply find remainders in each numerator term. Now the total gives us 6 plus 3 is 9, 9 plus 1 10, 17. So that is 17 divided by 7, which gives us the remainder equal to 3. So that is how the question should be solved. Let us try one more question with a multiplication now. The question is 395 into 1283 into 970 divided by 8. Now once again, we don't need to solve this whole multiplication in the numerator. What we need to do is, once again, we have to solve the remainder in each case of the numerator. So the first number is 395 divided by 8. The remainder in this case will be 8 4s 32, 7 remainder 75, 8 9 72. The remainder would be 3. Then 1283. Now here I know the test of divisibility is applied on the last 3 digits, so I need not check the whole number. I need to check only the last 3 digits, which is 283. So 8 3 is 24, 4 remainder 43, 8 5 is 40, 3 remainder there as well. Then the next number is 970. 8 ones 8, 17, 8 2 is 16, 10, 8 ones 8, 2 is the remainder. See, what we did here is we have avoided the huge calculation of multiplication of these three numbers. Now I am left with simple multiplication. 3 3s is 9, 9 2s is 18, 18 divided by 8, and the remainder in this case is 2. So such a huge calculation can be done in a very less time if you know this theorem, which is called as remainder theorem of multiplication, which is obvious. So we have learnt two theorems so far. One is remainder theorem of addition and the second is remainder theorem of multiplication. Let us try to use this theorem in the next question. What is the remainder when 1021, 1022, 1023 is divided by 12? So these numbers are consecutive, so we have an advantage here. If we find the remainder in the first case, we should be able to find the remainder in the second and third case very easily. So 1021 divided by 12. 12 8 is 96, 6 is the remainder, which makes it 61. 12 5 is 60, 1 is the remainder in the first case. Now since 1022 is a consecutive number, the remainder must be equal to 2, and 102, sorry, this is not addition, this has to be multiplication, right? Yeah, and 1023 is again a consecutive number, so the remainder there should be 3. So divide by 12. So the numerator gives us 3 into 2 into 1 is 6, 6 divided by 12. Now if you remember, the numerator here is smaller than the denominator, so the numerator itself should be the answer. So remainder here is 6. Fine. So imagine once again the amount of time we are reducing by avoiding the calculation of these three numerators, right? So this is the meaning of remainder theorem. Okay, we have learned what is positive remainder, what is negative remainder, and we have learned also the remainder theorem of multiplication and addition. Okay, these four things we have learned today. We have also learned one more shortcut. Whenever the numerator is smaller than the denominator, then the numerator itself is the remainder, right? So four things we have learned. Let us try to use it in the coming video to solve difficult level of questions. I am giving you homework here. I expect you all to solve these four questions, right? And this fourth question, question number D, is an interesting question because we are going to deal with such questions in the coming video. Comment yes if you like the video and if you understood the questions that we have discussed today. Thank you.